Hello guys, welcome to Infinite Insight Geometry, lesson 1.5, Biconditional Statements. Alright, let's begin. So, a conditional statement, as we've seen in 1.3, is a logical statement consisting of a hypothesis and a conclusion. For example, if a shape is a triangle, then it has three sides. A shape is a triangle is the hypothesis, and it has three sides is the conclusion. Well, the converse we talked about in 1.4 is a modification of a conditional statement, where the hypothesis and the conclusion are switched. So, the conclusion becomes the hypothesis. A shape now has three sides, and the hypothesis is now the conclusion. It is a triangle. So you switch it up. But what happens if you want to say that the original conditional and its converse are both true? This makes it easier to prove things because you can say if this equals that, then it's just easier to understand everything. So that's where biconditional statements comes in, because a biconditional statement is a conditional statement where the original and its converse are both true, and it's denoted by the phrase if and only if. A shape is a triangle if and only if it has three sides, because if it doesn't have three sides, then it is not a triangle. And if a shape is not a triangle, then it does not have three sides. So the fifth type of modification, we've talked about the original conditional. We've talked about the converse, the inverse, and the contrapositive. Now we're talking about the biconditional. P, if and only if Q. The hypothesis, if and only if the conclusion. This is where original conditional and the converse are both true. And a good example of a biconditional statements are geometric definitions. For example, a right angle is an angle with 90 degrees. The definition can be written as a biconditional statement. For example, if an angle is a right angle, then it has 90 degrees. And it works the other way. If an angle has 90 degrees, then it is a right angle. Both the original conditional and its converse are both true. And if either of the original conditional or the converse were false, let's say if the converse was false, then the biconditional will also be false. And that also goes for the conditional. If the conditional is false, then the biconditional is also false. And that will be all for today's lesson. If you liked the video, please like, subscribe, and comment. If you have any questions, my Gmail is in the description. And I will see you all in the next video.